Dear students, in this lecture, we are going to derive the characteristics of TEM waves. We know that for TEM waves, the value of M is equal to 0. Now, we are going to consider that the dielectric material between the two parallel planes through which the TEM wave is going to propagate is nothing but air. So, by considering air as dielectric and by taking the value of M as 0, we are going to derive a set of characteristics for TEM waves. The first characteristics that we are going to see is propagation constant. We know that propagation constant is represented as gamma, which is given by root of h square minus omega square mu epsilon. The value of h is given by m pi by a. And also we know that mu is equal to mu r mu naught and epsilon is equal to epsilon r epsilon naught. If air is considered as dielectric, so for air dielectric, the value of mu r and epsilon r will be equal to 1. Therefore, mu will be equal to mu naught and epsilon will be equal to epsilon naught. So, the value of gamma can now be written as root of m pi by a the whole square minus omega square mu naught into epsilon naught. Now, for TEM waves, m is equal to 0. Now, since m is equal to 0, gamma can be written as root of minus omega square mu naught epsilon naught. First term will be 0, right? Now, this can be written as root of minus sign is nothing but j square omega square mu naught epsilon naught. J square and omega square can be taken outside the square root. So it becomes j omega root of mu naught epsilon naught. We know that the propagation constant gamma is alpha plus j beta. Now here in TEM waves, this gamma is purely imaginary. It is purely imaginary for TEM waves. We don't have any alpha term, that is real term here. We have only the imaginary term which is related to beta. So we can say this is purely imaginary. So for TEM waves, alpha is equal to 0 and we can write beta as, beta is the coefficient of j term. So coefficient of j is omega into root of mu naught epsilon naught. So for TEM waves, alpha is 0 and beta is equal to omega into root of mu naught into epsilon naught. Let us move to the next characteristics. The second one is guided wavelength. Guided wavelength. The guided wavelength lambda g is given by 2 pi by beta. This is the formula, which is written as 2 pi by beta can be written as omega into mu naught epsilon naught for TEM waves. For TEM waves, beta is this. Now we know that 1 by root of mu naught into epsilon naught is nothing but V naught. So this can be written as lambda g is equal to 2 pi divided by omega. Omega is 2 pi by, this omega is 2 pi by f into root of mu naught epsilon naught. 2 pi will be cancelled and 1 by, this 1 by root of mu naught epsilon naught can be written as V naught. So this can be written as V naught divided by f. V by f can be taken as lambda. So this can be written as equal to lambda, which is nothing but wavelength of free space. So for TEM waves, lambda g, guided wavelength is equal to lambda, which is nothing but the wavelength of free space. wavelength of free space. Let us move into the third characteristics of TEM waves. The third one is velocity of propagation. Velocity of propagation, which is V is equal to omega by beta. Omega divided by beta, we know that for TEM waves, it is omega into root of mu naught into epsilon naught. This omega and omega gets cancelled. We will get this as 1 by root of mu naught into epsilon naught. 1 by root of mu naught into epsilon naught can be written as d naught, or simply it is c, the velocity of light. So here velocity of propagation is v is equal to c, which is the velocity of light, which is equal to 3 into 10 power 8 meters per second. The fourth characteristics for this TEM waves is nothing but cutoff frequency. Cutoff frequency FC. FC is given by mv divided by 2a. Now for TEM waves, we know that m is equal to 0. Therefore, FC is equal to 0. So we can say all frequencies above 0 can propagate along the guide. The next characteristics is characteristic wave impedance. Characteristic wave impedance. The definition for characteristic wave impedance is Ex divided by Hy, ratio of electric field to the magnetic field, which in case of TEM wave is beta divided by omega epsilon. Beta can be written as omega root of mu naught epsilon naught divided by omega into epsilon naught. Omega gets cancelled. We will get this as root of mu naught divided by epsilon naught, which is nothing but the intrinsic impedance eta. So we can write Ex as eta into Hy. The next characteristics of TEM wave is the total power propagating in Z direction. Total power propagating in Z direction. Now this can be calculated using Poynting theorem. It is calculated using Poynting theorem, which is given by gamma is equal to double integral x y e into h dx dy. Let us calculate this. Now as per Poynting theorem, we can write this as p is equal to integral x is equal to minus a by 2 to plus a by 2, integral y is equal to 0 to 1 ex by root 2 hy by root 2 into dx dy. And this is for 1 meter width along y direction. Now if we solve this integral, Ex, that is 1 by root 2, 1 by root 2, it becomes 1 by 2. It can be taken outside the integral. And Ex Hy is also constant, so you can take it outside. If you solve this, integral dx is x with the limit minus a by 2 to a by 2. Integral dy is, this is dy, y with the limit 0 to 1. If you substitute the limits and solve this integral, Ex Hy, this becomes a. The value of this is 1. So, here the power, total power propagating in z direction is given by 1 by 2 Ex. Now from this expression, Ex can be written as eta into Hy. So let us write it like as such here. And in the next step, we can write Ps 1 by 2 instead of Ex, eta into Hy. So it becomes eta Hy into Hy into A, and the power equation will be 1 by 2 eta Hy square into A. This is the total power propagating in the Z direction for TEM waves, and its units is watts per meter of width. So in this, we have derived the characteristics of TEM waves. We started with propagation constant. We have obtained the value of this as alpha as 0 and beta as omega into root of mu naught epsilon naught. Guided wavelength lambda g has become equal to lambda, which is the wavelength of free space. Velocity of propagation v is equal to the velocity of light, which is c. Cutoff frequency is 0 because m is 0 here. So cutoff frequency becomes 0. And the characteristic wave impedance is Ex is equal to eta into Hy. Finally, we calculated the total power propagating in the z direction, and it is given by 1 by 2 eta Hy square into E. Hope you understood this. Thank you.